Hello, everybody. Hope you're doing well. Today, I want to talk about an optimization problem. This is called the wire problem. In this problem, you're given a piece of wire and you're given a choice. You can take that piece of wire and you can bend it into a square. Or you can take that piece of wire, bend it into a circle. There's a third option. You can cut that wire. Part of it you can bend into a square, and the other part you bend into a circle. The questions that I want you to think about is what should you do to minimize the total area? And another question is what should you do to maximize the total area? So here's a precise statement of the question. If I have a wire that's 26 meters long, and suppose I do want to cut it into two pieces, one is bent into a square, and the other one is bent into a circle. Let's try to draw a picture of this. Okay, so this is going to be a little bit different in terms of the pictures that we normally draw. I'm going to have a piece of wire that's going to be 26 meters long. I'm going to cut this. Now, this cut, I will label it with a distance x. Now, what's the remaining distance? Well, it's 26 minus x. I'm going to bend this into a square. Now, I want you to think about what x represents. X represents the length of this wire. So that means that's the perimeter of this thing. The perimeter is equal to x. But the perimeter is also equal to 4 times a side length. So if this is the side length, S is equal to x over 4. So that means the area in terms of x for this particular square is s squared, but I really want it in terms of x, so that's x over 4 squared. So that's for the square. And this piece, I'm going to bend into a circle. Now, what does this length mean? This length is a circumference, so the circumference is 26 minus x. Well, how do we normally figure out perimeter or circumference? If I give you a radius, 2 pi r is equal to the circumference, which is now 26 minus x. Now, why am I doing this? Because I know that the area in terms of the radius is pi r squared, but I want the area in terms of x. Remember that I always want to get all these down to a single variable. I have my formula over here in terms of x. So I can take this equation, 2 pi r is equal to 26 minus x, and I can solve for r. R is equal to 26 minus x all over 2 pi. So that means in terms of x, I get pi times 26 minus x all over 2 pi, that whole thing squared. So what's my total area? Well, it's the area of the square plus the area of the circle. Now, before I continue, I'm always talking about, is this a closed interval problem or not? Well, let's think about x for a moment. Because we have control over x. X could be 0, and x could be 26. That's the largest it could be. If x is 0, how much wire goes into the square? None. If x is 26, all the wire goes into the square. So when x is 0, I just create a circle. When x is 26, I just create a square. When x is somewhere between, I create both, but I still can add them together. So this is a closed interval problem. So at this point, I hope you know what to do to finish this problem. Take a derivative, set it equal to 0, find the critical points, plug the critical points back into the original area function. You also need to check the endpoints as well, because this is a closed interval problem. And I'm going to leave it like this. The rest of the work is up to you. Now be very careful, because you can do this in an approximation way, but you can also do this in an exact way. So whatever method you choose, make sure you're following the directions given in the problem. I hope that was helpful. Have a great day, and let me know if you have any questions. Bye.